Uh, I know I had a health planning program. It's health program planning class that I signed up for with this, and I dropped it finally because I thought I can't do both. I'm just gonna.
Oh,
So
so we're doing group
I
meeting.
can't.
All right, so group meeting quiz, right?
yeah, this is group meeting, group number 7, lesson 6. So just quickly over part 1, do you guys get all the concepts that they're trying to teach us? Finding the mean, the sample mean of all the means, possible means, I should say. Do you guys get all that? Do we need to go over any of that?
Mm-mm.
Okay. All right.
Are you recording?
I am.
Yeah.
Okay. All right, so we're opening quiz.
Well, do you want to go over part 2?
Oh, I already opened it.
Oh,
Sorry. It's fine. We can do that because it says unlimited,
Okay.
right? I'm not going to time out.
No, you're not going to time out. Okay, so it's question 7 that they wanted us to select. Did you guys do that? Randomly select 5 of the 30 salaries and complete
Yes.
the mean? Okay. And then it said graph it. Go throw it on your graph. And then does your sample mean appear to be unusual? Explain why you think it is or is not. What did you guys think?
Mine was not. It was like just barely, not even a half a deviation away from the mean.
Yeah. Mine was like within 1 of the mean. So mine wasn't. What was that, Eduardo?
I think I didn't even do this. I don't know. I've been having problems with this. So hold on. Let me see the question. It was lesson 6, correct?
We'll say that one more time.
It's lesson 6.
The standard deviation or the mean?
The standard.
Yeah. Oh, yeah. Sorry. Lesson 6. Yeah, we're on lesson 6.
Okay. Just making
So
sure.
in part 2 on question 7, they had all those possible salaries, and you were supposed to randomly pick 5 and then compute the mean of that. The mean that I got with the 5 I got was 47,200.
Yeah.
And so
Well, technically, everyone's going to have a little bit different answer.
yeah, we're all going to have different answers. And that's on question 7D is they want to compare all of our answers. So if you haven't done it yet, go ahead and like randomly pick 5. Like I just kind of, in a sense, close my eyes and pick 5 with a pen. You can cut them out and select 5 different.
So we're trying to say the combinations, right?
Yeah, so you'll take the 5, add them together, divide by 5, and that's your mean.
Okay. Divided by 5. Okay.
So what was yours, Eduardo? What was your mean?
28,501.2.
Of all the salaries?
Yeah.
Okay. How did you get a 0.2?
Hold on. Am I supposed to divide by 5 or 30?
5.
Divide by 5.
What?
Because you took 5 samples.
Oh, my bad. Hold on. Sorry, guys.
You're fine. You're totally fine.
Okay, give me 1 sec, guys.
You're in good company.
Yeah. No pressure.
I tell you that I was lost because I was either on the wrong page or something. I had no clue what you guys were talking about.
I got 48.
I did this, but
160.
I'm not talking about the same thing.
You got, sorry, 48.
48,160.
160. Okay. And Carrie, what did you end up getting?
Hold on 1 second. I'm redoing my math.
Okay. Good.
I got 47,400.
I got 49,100.
Okay. 49,100.
Mm-hmm.
So they're all kind of like Chris's and mine would be within 2. Well, we don't really. Do we have the standard deviation? Anyway.
No, but I will tell you that most statistics, it's 2. Well, if you go back to the 95 rule, the 68, 95, that most are within 2.
Yeah.
That's the only thing I remember
Right,
from
because
taking
if
this class
greater
before.
than 2, it's unusual, right?
Yeah.
If it's greater than 2, it's an unusual reading anyway.
Right. Which we don't know what the standard, but they all seem pretty close within there. So I would say that most of them seem close and are usual. Okay, so they just wanted you to kind of put your mark on that graph, but one of the points of this thing is that's only 5 samples. If we were to graph 30 of these same things that we just did, then our graph actually would still just be bell-shaped and whatever. So you guys get all that. I think that's what they're trying to get at. So question 8, the graduate management admission test is used as an admission criterion in many masters of business administration. The scores on the GMAT are normally distributed with a population mean of 529 and a standard deviation of 113. Consider a random sample or a value of 10 students taking the GMAT. So on A, it says, what's the shape of the distribution of the sample means for all such samples?
Well,
the shape
is normal. This is normal because the parent is normal.
Yeah. So Chris, how did you come up with that answer?
Theorem says that if the parent shape normal, then the means is going to be normal.
Okay.
For a smaller sample.
Yeah, and so,
if it's a larger sample, then it's going to be normal, even if it's skewed.
Yeah. Well, and if you look up at the description of this, it said the scores on the GMAT are normally distributed. So it tells us that population sample is normal. So it's going to be bell-shaped. And that answers B as well. And then what is the mean of the sampling distribution of sample mean scores for all such samples? Carrie, you got that?
No, let's see. Let me, what I had.
Sorry to put you on the spot.
No, that's okay. We're on C, right?
Yeah.
529?
Yep.
The mean's going to be the same.
Same as the population mean. And then what is the standard deviation of the distribution of sample mean scores for all such samples? Who wants to take that one on?
I'll take it. That's the one where you take the 113 and divide it by the square root of 10.
Yeah. Yep.
And you come out with 3.162.
Was it 3.162?
Uh-huh.
Let me check. Sorry.
That's what I got on it.
Well, the answer key says 35.734.
Yeah, that's what I got. Let me just, sorry. Let me go.
Oh, it is. I got it. Never mind.
Okay.
Yeah, it's 113 divided by 3.162.
Okay. Awesome.
It's 35.737.
Let's see.
4.
So I have a question about doing the square root.
Yeah.
So in the orders operation, do you do the square root before you do the division?
I do. I do the square root. Well, so I go find the square root, which is
3.162 is.
Yeah, 3.1
square root.
Yeah, 3.162. So I got 35.736, depending on how they want us to round it.
So you round it before? Because I thought
No.
they always tell you not to round it until the final.
Yeah, I didn't round it. I rounded the square root because it would be, well.
Because that potentially could give you a wrong answer if you square root. I mean, if you round it off before. I mean, you'll only be. The problem is, like, when we fill in the blank, you know, it's one thing if you have 5 options and you're like, oh, I'm only 1 point off, versus
it's gotta be
writing
that.
it in. You know what I mean?
Right. What did the? I'm looking. I put down 35.759. Don't ask me why. Probably because I rounded it before I ever put it in there. But I'm gonna go look at the prep answers just to make sure. What was that?
On the fifth, but I don't have it, but I have it in parentheses. 35.734. I don't know if
Okay.
that's
Let's see. Okay. Sorry, I'm getting there. My computer decided to be slow. Okay. Let's see. Seriously, computer, let's go.
So how you set it up
Okay.
is you're going to take the mean is what you do the square root of, right?
The DV, let's see. No, you take the square root of the value, the sample. So n was 10. And
Oh,
so
but deviation goes. I thought it was the mean.
we're finding the deviation.
Oh, that's right. The mean. The mean. I'm just confused. Okay.
You're fine. So.
Whoops. Because I found what? Go back.
Okay.
Okay, so 113 divided by the square root of 10 equals 35.7337, which we would, they say unless told differently, we round to the third. So it'd be 35.73, and then the 7 makes the other second 3 a 4.
Yep, that's the right answer.
4.
Yep.
And then, you know, we already said that it's normally distributed.
Okay.
Distribution.
3.16. Okay. Awesome. All right. Well, I think we're ready to go take the quiz. Everybody ready?
Yes.
Ready or not? Here we go. Okay.
Quiz.
All right. Let's go do that. Sorry, I'm getting in. I was in there and then I went somewhere else for a second. Okay.
Do 1 and 2, everybody, on your own.
Yes, do 1 and 2 because it really messes with your schedule.
Those are free points. Don't give them up.
That's right. We need all the points we can get. We're wanting a C.
Statistically, I will not have that happen.
Okay. All right. I'm done with 1 and 2. Phew.
Okay.
All right. Question 3. When you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
It's going to be right skewed because sample is less than 30.
Yeah. Yeah, I think you're right. I think it would follow the same. We just don't have enough samples to make it normal.
And say, isn't it the not normal because it's not a large, is not considered?
Right. They don't have not normal as an option.
Right. I'm just talking it out.
Yeah.
So wouldn't it also still be skewed to the right?
Yes.
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 That's what I've got. We'll see.
It would follow the same shape. All right. Is everybody good with that?
I'll do 4. When you're taking a sample size of n equals
right,
100.
Right. Sorry.
We said it's the same, skewed right.
Okay.
What is the shape of the distribution of means histogram when the parent population is right skewed? Isn't that normal because isn't 100 considered?
30 is considered a large sample.
Yeah. So if it's 100, for sure.
So it'd be normal, right?
Yep.
Or am I thinking this completely wrong?
No, that's right.
Well, if you are, we all are.
Okay, well, we've been there too.
Right.
If one goes down, we all go down.
Right. No, they said for this course, consider 30 to be a large sample and that it would make it normal, a normal distribution.
Okay.
All right. Who wants 5?
5 says when you're taking
do 5.
When you're taking a sample size with n equals 5, what's the shape of a distribution of means in histogram when the parent population is normally distributed and it would be normal?
Yes, because the key is it says right there, normally distribution.
Right.
Yep. Absolutely.
Wait,
See,
sorry.
once again,
Sorry.
worst word problems ever.
What was that, Eduardo?
All right. So 4 is skewed left?
No, 4 is
4 is normal.
How would that be normal?
Because it's the population sample of n equals 100 is more than 30.
This is on 4.
Oh yeah, okay. I got you now.
So
So,
then
0 to 30 is right skewed, and then the rest is like.
If I understood the video correctly, once you are considered a large sample, you go into normal, right?
Okay. Uh-huh.
I mean, they put it in layman's terms.
Yeah.
Well,
and I totally did air quotes all by myself.
Yeah, it's that theorem of central limit. Yeah, that's what makes it. It's the central limit theorem. It says either if the parent population is normal, then it's going to be normal, or if you have a large enough sample size, it will be normal. So.
Okay.
All right, question number, are we 6?
Mm-hmm.
Okay. When you're taking a sample size of n equals 5, what's the shape of the distribution of means histogram when the parent population is normally distributed? Wait, did we do this?
5.
Yeah, I didn't say that. You just read 5.
I was going to say, wait, we just did that. I just hadn't pushed saved yet. Oh, that's 5. That's why. All right. When you're taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? It would still be normal.
Normal.
Okay.
Okay. All right. Who wants 7?
I'll do it.
Sim.
Well, go ahead, Chris. Go ahead.
Go ahead.
No, you go ahead.
Says when would the distribution of means be normally distributed, and you choose them all. And I've got the first one, the second one, and the fourth one not marked.
Okay, so data are drawn from population that's normally distributed and the sample size is small.
Right, that would make it normal.
Okay, data are drawn from population that's normally distributed and the sample size is large. And
that
then
would still make it normal.
And data are drawn from a population that's right skewed and the sample size is large.
It would still make it normal.
Yep, I agree.
Okay.
All right.
All right, now I have a question on 8, so I'm not going to
Did you move ahead, Chris?
Well.
Yes.
Just because I marked that one faster, but 8 I have a question on, so I don't know the answer to it.
Okay, I'm looking at it.
Which of the following gives the best explanation of the central limit theorem? If a parent population from which the data is drawn is normally distributed, then the sample mean will follow a normal distribution. For bell-shaped data, approximately 68% of the data will be within 1 standard deviation of the mean. About 95% of the data will be within 2 standard deviations of the mean. And approximately 99.7% of the data will be within 3 standard deviations of the mean. I don't think that has anything to do with central limit theorem. Yeah, if the sample size is large, the sample mean will be close to the population. I remember that from the video.
That's except that is the definition.
Standard deviation, though, isn't it?
No,
Yeah.
that's the
large number. Oh, that's the large number.
Of large numbers, right?
Oh no, the last one's the large number. If the sample size is large, the shape of the distribution of sample means will be approximately normal. But I actually print out the book, so it's in my son's wrestling bag. Hold on one second.
Okay, so the first one is true. Right?
Yeah, that one follows the central limit. The parent population is normally distributed, then the sample mean will also follow a normal distribution.
Okay, so what's with the last one? Because isn't that one true too?
No, that's the large number.
No, the shape is that's the large number. Okay, all right, I got it.
Okay,
Well, I thought the shape, though. I thought the large number had to do with the means would approximate. Oh, never mind. That's what it says. The means. Okay. Yep. All right.
Okay, so according to the book, it says, in other words, the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. This important result is called the central limit theorem. This is arguably the most important concept in all statistics.
Right, so that's...
So is that the first one?
So the first one follows the central limit theorem. But it almost feels like the last one could.
See, that's the one
No, I think the last one is large. Okay. How many observations are required so that the central limit theorem will assure that the distribution sample means will be approximate normal? The answer is it depends. Okay, here it says, if the parent population is normal, then the sampling distribution of X will always be normally distributed no matter how many observations are selected.
Yeah, which is the number one on that question.
And then the second bullet point says, if the parent population is not normal, then the sampling distribution X will be approximately normally distributed, if I could say it right, distributed if the sample size is large enough.
Yeah. Well.
But okay, so now maybe I'm confusing myself. The large number one talks about the spread, and the central theorem talks about the shape. So is it 1 or 4?
Well, to be honest, I would say both, but we can't. I would pick I say we'll pick the first one.
Okay.
And then we can go from there, because that, to me, it's a little too confusing. I don't know, they were trying to be tricky, but it feels like 4 could have been answered the same.
Said the shape of the distribution, which is the central theorem, because the spread of the distribution is a large number.
Okay, so on page 6 it says, it's talking about the large numbers, the law of large numbers. It says, notice that this is very different from the central limit theorem. The central limit theorem states that if the sample size is large, that X will be approximately normal. The law of large numbers states that the sample mean will be close to then the little u, which is also mean, which would be this. Okay. That was confusing me. The sample mean and the population mean will be close.
Oh, we're just confusing ourselves. Let's go with the first one, and then we'll look at it.
We're going with the first one? Hello?
Yeah, Eduardo, I can hear you. Can you hear me?
Right?
Yeah, we're going with the first one. But that just, it's a little confusing. I hate questions like that.
It could be C too, couldn't it?
C is the law of large numbers.
Oh.
And so, I know it's also confusing, especially when they're so close.
Yeah. Okay.
Okay. All right. Do we want to? We'll pick one, and then one of us will turn it in, and we'll see what it is. All right. Let's go down.
Go with the first.
Yeah, we'll go to the first one. All right, question 9. So they're giving us the information, X be a random variable with population mean at 10 and the population standard deviation at 6. Suppose a sample size of 36 is drawn. So question 9 is, what is the mean of the distribution of the sample of means?
It's the same as the other mean.
Yeah, so 10. Yeah. Okay, so then we go down to 10. What is the standard deviation of the distribution of sample means?
Okay, so that's when we do the square root thingy, right?
Yeah, so you take you take the standard deviation of 6 and you divide it by the square root of
36
of the sample size. Yep.
Comes out to be 1.
Yeah.
Yeah. Okay. All right. Question 11. Regardless of the
what was that?
Go ahead.
Okay, the mean is 10, right? So that's
Yeah.
so it's 6. Let me just work this out. So it's 6 divided by the square root of 10, right?
No, you
No,
actually
divided
used
by
the
the square.
sample size, which was 36. So the square root of 36.
Okay. Oh, I'm so stupid. Ugh. Okay.
You're fine.
I said mean is 10, and then I still used it. Okay. Okay, so number 11.
Go ahead, Carrie.
Oh, it said regardless of the distribution of the population, if the sample size is large and is larger than 30, what would be the shape of the distribution of the distribution of the sample mean? We're still back to normal, right?
Yeah.
I would agree.
I mean, from what we've been preaching to ourselves all night.
It would still
What
be
we've been
normal.
confusing ourselves with. Yeah, I
Okay,
agree.
and then-
It'd be normal.
Question 12.
All right. What theorem would justify your response in the last question? And I would
Well, it better
say,
be the central limit theorem.
I was saying, isn't that what we were saying?
yeah.
Okay,
Yeah.
All right. Do you guys want me to submit it?
go
Sure.
for it.
All right. I'm going to submit. Okay. 100. Oh, no, we missed one. Okay, let's go back up and find it. I'm going to see it. Okay, it's that one that we were debating on.
Number 8.
Yes. So one of you change it to number 4 and turn yours in.
Okay,
If the
I'm doing
sample
it.
size-
I'm
Okay.
doing it. Sample size, the last one.
Silly thing.
I questioned that one and questioned that one and questioned that one. I jock.
Well, you know what?
I got 100%. It's the last one.
Okay, it's the last one. I'm mad.
Okay.
That's stupid because not.
I
Sample
I was
mean.
leaning toward number 4, but I have to say, like, the more we talked about it, the more confused I became.
Yeah.
Right. So we should just stop talking, right?
Well, then on the homework, I'll have a completely different answer. So
Right. Oh,
Yeah,
funny.
because right. To tell me what's wrong with the first one then.
Right. That's my question too. Sorry, someone's calling me, but I'm not going to answer it. Sorry. I'm just gonna.
Nice ringtone.
Yeah, I can't figure out what's wrong with it because it seemed. Well, the only question I would have on it was, is there a wording issue? For example, if the parent population from which the data is drawn is normally distributed, then the sample mean will follow a normal distribution.
I think that's.
I'm wondering if. Go ahead.
Oh, I don't know. I was thinking out loud. Go ahead.
Maybe it's then the sample mean. Maybe we're just putting in.
The first one felt very much like what he was talking about, the normally distribution, where it says regardless of the sample size, the shape of the distribution of sample size means is normal.
Yeah.
See, I think the fact that it threw the mean in, no, because the last one says sample means too.
But it says the distribution of sample means, which is talking more about a shape. I don't think does the mean actually have a shape.
No, because the
That
mean's
makes
right in
sense.
half. I mean, it's
Yeah.
No,
So I'm
but
wondering if that. Go ahead, Carrie or Chris.
no.
I wonder if that term distributed. I wonder if that's talking about the spread. If something was
Yeah.
to one end to the other, I wonder if that's where the thing is.
Yeah. That's what I'm guessing is just a matter of words there that they put something in. So in our mind, it sounds right because we're saying, well, yeah, population is normal. That means that it's normal. But I'm wondering if it's that sample mean. It's not, the mean isn't a shape. But anyway, awesome. Well, I hate being tricked, but that's okay. I'm all right.
Thank goodness for teamwork.
That's right.
Just
That's
hope they
right.
don't trick us on the exam.
You what? Sorry, Dorla.
I just hope they don't trick us on the exam.
Oh,
I
yeah.
know. I hope
I swear
not.
we should all be taking the homework quiz together. Just oh, we're recording. Never mind.
All right. All right.